Welcome back mga kabulero at ito ang continuation ng ating Rotational Kinematics discussion. At ngayon, magdi-discuss tayo ng iba-ibang problems related to Rotational Kinematics, and what is exciting today ay yung mga problems na isa-solve natin ay merong konting twist at ginamit ko ngayon yung mga names ng mga kaibigan ko nung college, and shout out sa inyo kung nakikinig kayo ngayon. So let's solve problem number 1. Ang problem number 1 says, Demetrio is a professional cyclist and he rides his bicycle having a wheel diameter of 62.2 centimeters and the wheels are spinning at a constant angular velocity of 2.5 radians per second. The question is, or the questions are, how many revolutions will the wheel go through if he traveled for 10 minutes? And second is, what is the total linear distance covered by his bicycle using the same time interval? So the given are, number 1 is diameter, which is 62.2 centimeters. And we also have yung angular velocity designated by omega. That's 2.5 radians per second. And we also have yung time, which is 10 minutes. So kung mapapansin natin, meron tayong diameter, pero ang kailangan natin is radius. So let's solve for radius. The radius would be just half of the diameter. So divide lang natin sa 2. This is 62.2 centimeters. And divided by 2, that's 31.1 centimeters. Hindi na ako magagamit ng calculator. And then, kailangan natin siyang i-convert into meters para ma-follow natin yung unit convention using metric system. Multiplied by 1 meter, this is 100 centimeters. Magkakaroon ng cancellation of units. And the answer here is 0.311 meters. Okay? So, na-convert na natin yung distance or yung radius natin into meters. Also, we have the time. We have to convert this into seconds. Kasi nga, ang mga units na kailangan natin ay meters and also in seconds. And also radians. So, let's have this factor 1 minute or 1 minute sa ilalim para magkaroon ng cancellation of units. And then we have 60 seconds on top. And the answer here is 600 seconds. Okay, so we are now ready to compute for our first required quantity, which is the number of revolutions. So bago tayo makapag-solve ng number of revolutions, kailangan muna nating isolve si theta. At ano nga ba yung theta? So let's have the solution in here. So theta is the angular displacement. So the formula for the angular displacement is omega t, diba? Halos ano lang yan, kung i-compare natin to in linear displacement, ang formula nun is S is equal to Vt, diba? Ito yon. So yung distance is equal to velocity multiplied by the time. Magkakaroon lang ng cancellation ng units at ang matitira dito is in meters. Pero iba sa angular motion. Ang unit kasi nito is radian per second, at kung magdi-divide or mag-multiply tayo ng time which is in seconds, ang matitira dito is in radians. So ito yung parang na-displace na angle. Kaya nga ang tawag is angular displacement. So let's substitute. The angular velocity is 2.5 radians per second. Ilagay ko sa ilalim yung per second. At magmumultiply lang tayo ng time which is 600 seconds. Cancellation of units, and then your theta is equal to 2.5 multiplied by 600. So, calculate natin. 2.5 times 600. The answer is 1,500. And this is in radians. So, hindi pa tayo pwede huminto dito kasi nasosolve pa lang natin yung angular displacement. Kailangan natin ng mag-multiply ng factor para makuha natin yung number of revolutions. At kung aalalahanin natin, meron tayong conversion ng radian into revolution. Kailangan lang nating mag-multiply ng factor which is, ito yon, 1 revolution is equal to 2 pi radian. Okay? So, 2 pi is just the complete cycle sa isang circle. So, kaya siya 2 pi radian. At magkakaroon ng cancellation of units. At masasolve na natin kung ilang ikot yung nagawa sa scenario na to. Or yung nangyari sa scenario na to. And the answer is, let's compute. That's 1,500 divided by 2 pi. So, sana nasusundan niyo kung paano ko plinag in sa calculator. The answer would be the same if your calculator is set to degrees or in radian. The answer is 238.73 revolutions. Okay. So, nasolve na natin yung first required quantity. So, ang susunod natin isosolve base sa problem is, what is the total linear distance? So, kapag sinasabing linear distance, given meron kang angular displacement, edi, naalala natin, kailangan mo lang mag-multiply ng radius. At masasolve mo na ngayon yung linear displacement. So, S, di ba, is equal to radius multiplied by theta. At alin ba yung gagamitin natin? Ito bang radian na theta or yung theta in revolution? Siyempre, yung theta in radian. Kasi ang radius is naka-default siya in meters per radian. So, lagay natin yung radius which is 0.311 meters per radian multiplied by theta which is 1,500 radians. Okay? So, cancellation of units, and S is equal to, gamitin natin yung calculator, we have 0.311 multiplied by 1,500, and the answer is 466.5. And the unit is in meters. So, ibig sabihin, ito yung na-cover na distance ni Demetrio kapag meron daw siyang angular velocity or angular speed na 2.5 radians per second at yung gulong is measuring 0.311 meters in radius. At sa 10 minuto or 600 seconds, ito yung mako-cover niyang distance. Okay? At ito din yung revolution. So, 238.73 revolutions. Napakaganda na ginagamit natin ngayon yung kinematic equations natin or yung idea natin about linear sa angular motion kasi halos parehas lang din yung concept. Okay, so let's proceed to our next problem. Eric, who is a construction engineer, turns his sander on to smooth a surface of a rough wood project. Having a constant angular acceleration of 120 radians per second squared, the questions are, what is the final angular speed of the disk of the sander after 10 seconds of use? B, how many revolutions will the disk go through during this time period? And C, what is the linear speed of a point at the edge of the sander's disk after 10 seconds if the radius of the disk is 6.5 centimeters. Parang sobrang daming hinihingi dito. Pero let's break it down one by one. So let's first write the given. Ano nga ba? Meron tayong alpha or the angular acceleration which is 120 radians per second squared. Meron din tayong time. Okay? Time is equal to 10 seconds. And we have radius which is 6.5 centimeters. And then, ano pa ba? Meron tayong initial angular accelerate or angular velocity, which is, di ba, kaka-turn on niya lang. Kahit hindi siya na-mention sa problem, pero napakalinaw nun. Okay? So, initial angular velocity, which is 0 radians per second. At gagamitin natin to kasi may mga isosolve tayo mamaya na nangangailangan ng initial velocity. At actually, yun yung letter A. So, what are the solutions for the succeeding requirements? So, letter A is asking for the final angular speed. So, yun na yun, angular velocity. At meron tayong given na initial angular velocity, which is 0 radians per second. So, ang hinihingi is yung final. So, to solve for the final angular velocity, kailangan natin gamitin yung kinematic equation natin, which is the second kinematic equation, saying omega f minus omega or O, diba? Or initial angular velocity is equal to plus or minus angular acceleration multiplied by the time. So, sa sign convention na to, ang napakalinaw kasi nag-accelerate siya from rest or hindi siya umiikot nung umpisa at kaka-turn on lang. Ibig sabihin nun, meron siyang acceleration. So, yung sign natin ay magiging positive. So, hindi ko na isusulat. Therefore, this is 0. And then, your final angular velocity is equal to alpha t. And you have your 120 radians per second squared, ba? Multiplied by the time, which is 10 seconds. Okay? So, 10 segundo niya lang pinagana yung sander para magawa yung project niya. And the answer here is, let's compute. So, huwag na natin gamitin ng calculator kasi napakasimple lang. Your angular or your final angular velocity is equal to 1,200 radians per second. Okay? So, nasolve na natin yung first required quantity, which is yung final angular velocity. Letter B is asking how many revolutions. So, previously, nag-solve tayo ng revolution at dumaan muna tayo sa angular displacement. So, let's solve for the angular displacement. Lagyan natin ito letter A. Lagyan natin letter B. So, angular displacement is again computed as omega or angular velocity multiplied by the time. But this time, meron tayong kasing acceleration. Applicable lang yung angular velocity multiplied by the time kapag meron tayong uniform speed or zero acceleration. Dito kasi meron tayong acceleration, therefore, kailangan natin gamitin yung first kinematic equation. So that is omega sub ot, which is ito yon yung walang acceleration. Paano kapag may acceleration? Eh, di magpa-plus tayo ng 1/2 alpha or yung angular acceleration multiplied by the square of the time. Sana naaalala natin to. This is the first kinematic equation. And ito, wala na to. Okay? And then, ang matitira, 1/2 of our alpha, which is 120 radians per second squared. At magmumultiply tayo ngayon ng t squared or that's 10 seconds squared. So, naka-square, square, square. Ang matitira dito is in radian. So, our alpha is equal to, calculate lang natin, that's 0.5 multiplied by 120 multiplied by 10 pero naka-square. Okay, the answer is 6,000 radians. Okay, pero ang hinihingi is number of revolutions. So, we have to convert. Therefore, magmumultiply lang tayo dito ng factor. Ano nga ba yung factor? That is 1 revolution tapos 2 pi radian sa ilalim. Okay, cancellation of units for the radian, and your theta, or the angular displacement, or the number of turns or number of revolution is equal to 6,000 divided by 2 pi. And the answer is 954.93 revolutions. Okay, nasolve na natin agad yung second required quantity. At ang letter C is asking for the linear speed at the point, at the edge of the sander's disk after 10 seconds. So, ibig sabihin, after 10 seconds daw na pagpapaikot ng sander, ano na nga ba yung final velocity? 'Di ba? Parang yun yung tinatanong, linear speed eh. So, ano na nga daw ba yung final velocity? Pero linear velocity yung pinag-uusapan. That's the VF. Okay? Pero pwede naman natin sabihin na V lang. Pero specific kasi tayo dito na yung initial velocity niya is 0. Okay? So, yung final linear speed is, alam natin, mag-multiply lang tayo ng radius para makuha natin yon. Kasi meron tayong angular velocity. So, radius multiplied by the angular velocity. Ilagay natin yung final angular velocity para napaka-specific. Meron tayong radius. Okay? 6.5 centimeters. At i-convert muna natin siya into meters. So, mag-multiply tayo dito ng factor na 1 meter over 100 centimeters. Okay? At ang kakalabasan nito ay 0.065 meters. So, yun yung magiging radius dito, 0.065 meters multiplied by WF is equal to 1,200 radians. Okay? Actually, 0.65 ito per radian to per second. Okay? At ang makukuha natin dito, magka-cancel muna tayo ng mga units. So, your final linear velocity is equal to, calculate lang natin, 0.6 times 1,200. At ang kakalabasan niyan ay 78 meters per second. At yan, nakuha na natin yung pangatlong required quantity, which is the final velocity. Okay, so yan yung mga relationships na nakuha natin sa second problem. And let's proceed and solve for the third problem. So for problem number 3, sabi dito, Paulo came home tired from work, increases the fan speed of their electric fan from 60 radians per second to 100 radians per second for a second. And the fan blade is measuring 16 inches in radius. And the required quantities are, first, how many revolutions will the fan blade go through during that time period? Second is, what is the average angular acceleration of the fan blade? At third is, what is the average linear acceleration of the fan blade? Medyo madami na naman hinihingi. Pero, let's write down the given. Ano-ano nga ba mga to? Una, napakalinaw na sinabi, we have the initial angular velocity, which is 60 radians per second. We also have yung final, di ba? Kasi nga merong variation or pinataas niya. Siguro pinindot niya yung button na from number 1 naging number 2 or number 3. Kaya ganun yung increase ng angular velocity. So we have 100 radians per second. And we also have the time. Ang time natin dito is 1 second. Siyempre, hindi ka naman aabutin ng 2 seconds. So, pipindutin mo lang yung button. So, we also have the radius. At ang radius natin dito is 16 inches. So, ituloy na natin agad-agad. I-convert natin yung 16 inches into meters. Diba? So, that is, mag-multiply tayo ng factor na 1 inch sa ilalim at sa ibabaw is 2.54, that's 0.254. Okay? And this is in meters. So, kinonvert ko lang. And then the answer is, let's compute, 16 multiplied by 0.0254. And the answer is 0.4064. Okay, sige. Yung kunin ko na lang yung tatlo. 0.406. Okay, that is already in meters. Okay, so let's solve for letter A. And letter A is how many revolutions? Therefore, dadaan muna tayo sa theta. And theta is equal to, wala namang sinabi ditong acceleration. And therefore, pwede natin gamitin yung omega, di ba? Yung mga velocities na nakalagay dyan. So, to solve for the theta or yung angular displacement, ang kailangan natin gamitin dito is yung average na velocity. Kasi hindi naman pwede na gagamitin lang natin is initial or yung final. Therefore, kailangan natin dito is yung average. Okay? The average velocity multiplied by the time. So, to solve for the average velocity, edi add lang natin yung dalawang velocities, angular velocities, and then divided by 2. Okay? So, that's 60 radians per second plus 100 radians per second. Okay? At saka, imumultiply natin siya sa time, which is 1 second lang. And then, kung titingnan natin, magkakaroon ng cancellation of units, yung mga seconds mawawala, at ang ating theta or angular displacement would be, let's solve. We have 60 plus 100 divided by 2, that's 80. And then, multiply lang ng 1 second, it's still 80. So, this is 80 radians. Okay? And as we remembered, to solve for the number of revolutions, mag-multiply lang tayo ng factor na 1 rev divided by 2 pi radian. Okay, cancellation of units, and our number of revolutions, okay, number of revolutions here is 80 divided by 2 pi. And the answer is 12.73 revolutions. Okay? Alright. So, in 1 second daw, pagka ganun yung nangyari na tinaasan lang ng 40 radians per second, kasi galing siya sa 60, naging 100, in 1 second, ganito yung magiging displacement, angular displacement. And in terms of revolution, that's 12.73 na ikot ng fan blade. So, to solve for letter B, ang hinihingi for letter B is, what is the average angular acceleration of the fan blade? At kung hinihingi is average angular acceleration, ano nga ba yun? That would be yung angular acceleration na galing sa second equation ng kinematic formulas natin. So that is omega F minus omega O, or the final minus the initial, multiplied by yung angular acceleration multiplied by the time. Ito lang yun. So, angular acceleration is equal to, syempre, omega F minus omega O over time. And let's substitute. Omega F is 100 minus 60. Diba? Naka-radian per second to. And then, yung time is 1 second. Magkakaroon ng multiplication yung seconds. Kaya magkakaroon tayo ng unit na. So, angular acceleration is equal to 100 minus 60. That's 40. Divided by 1 second, it's still 40. But the unit is radian per second squared. Okay? Napakadali lang nung pangalawa. And now, let's compute for our third required quantity, letter C. And ang hinahanap dito is yung linear acceleration. So, nasolve natin yung angular acceleration at alam natin mag-multiply lang tayo ng radius. So, linear acceleration is equal to radius multiplied by our angular acceleration. And that's 4. Isulat natin muna yung radius. That's 0.406 meters. Diba? Multiplied by, so, per radian. Okay? At dito is 40 radian per second. So, magkakaroon ng cancellation ng units. And then, your linear acceleration, let's compute. That's 0.406 multiplied by 40. The answer is 16.24 meters per second squared. Okay, so nasolve na natin yung number of revolutions, our average angular acceleration, at yung huli is yung average linear acceleration. And that's all for problem number 3. At next, dadako tayo sa ating last problem. Okay, so for our last problem for rotational kinematics, this is about Jerry John. And Jerry John fetched his new girlfriend in the airport, or from the airport, with his motorbike. And the wheel diameter of his bike measures 60 centimeters. And he speeds up from 100 radians per second to 140 radians per second. Siguro nagpapasikat to si Jerry John, kaya binibilisan. And the linear acceleration of the edge of his bike's wheel is 20 meters per second squared. So, ang tinatanong ay, number 1, how many revolutions will the wheel go through during this period? And, syempre, nag-accelerate siya or nagkaroon siya ng change. Yes, nag-accelerate. So, how far is the distance covered after accelerating? So, sulat muna natin yung mga given. Number 1 is we have yung diameter, which is 60 meters. So, kunin lang natin yung radius nun. Radius is equal to diameter over 2. And that's 60 centimeters divided by 2. This is 30 centimeters. And i-convert lang natin siya into meters. So, 100 cm sa ilalim at 1 meter sa ibabaw. The answer is 0.30 in meters. We also have yung angular velocities. We have the final and then the initial. We have 140 radians per second yung sa final. 100 radians per second yung initial. And we also have yung nakalagay dito is linear acceleration. Okay? Which is designated by A. That's 20 meters per second squared. Okay, let's solve for the first required quantity. And ang hinahanap dito is, syempre, how many revolutions daw. Pero bago natin makuha yung number of revolutions, hindi natin kasi siya agad-agad masosolve. Okay? Kailangan muna natin daanan or isolve muna yung angular acceleration. Kasi dapat, para masolve natin yung angular displacement, kailangan muna natin isolve yung angular acceleration. Kasi walang direct na solution from linear acceleration to angular velocity or angular displacement. So, let's solve first for the angular acceleration. And for letter A, ang hinahanap natin ay yung angular acceleration. So, given the linear acceleration, you can compute for the angular acceleration. Ito yun. Ito yung kailangan natin. I-divide lang natin siya sa radius kasi the other way around. Angular acceleration is equal to A over R. And that's A is 20 meters per second squared. And we have yung radius natin na 0.3 in meters per radian. Okay? So, cancel si meters at matitira is radian per second squared. Okay? So, your alpha is equal to, computin natin, we have 20 divided by 0.3. So, that's 66.67 radians per second squared. Okay? First level unlocked. Okay? Hindi pa to yung final answer. Let's compute for theta. Pero ano nga ba, alin nga ba dun sa tatlong kinematic equations yung merong appearances ng theta at saka ni alpha or ni alpha at saka ni theta. At ito yung third kinematic equation for angular motion, and that is omega f squared minus omega o squared, or the final velocity minus the initial velocity at parehas sila naka-square, is equal to, syempre nag-accelerate, hindi ko na isusulat yung ambiguous sign na positive. That's 2 alpha and then theta. Okay? This is the angular acceleration. This would be the angular displacement. At masasolve na natin ngayon yung theta kasi meron na tayong final velocity, initial velocity, at saka yung acceleration. Okay? So, i-divide lang natin to dito sa baba. And kung gagawin natin ganito yung format, theta is equal to omega f squared minus omega o squared divided by 2 alpha. Okay? Sana nakasunod. Ilagay natin yung given. We have 140 minus 100. This is in squared na to. Tapos, radians per second. Tapos, i-square na lang din natin to. And then, we have 2 times alpha, which is 66.67 radians per second squared. Okay? Sana magkasya yung ating computation. And our theta is equal to, let's compute, 140 squared minus 100 squared. Ito muna tayo. Equals, that's 9,600 divided by 2 times 66.67. Okay, and the answer is, kunin ko na lang whole number, which is 72 radians. Okay, magkakaroon lang naman ng mga cancellation of units dyan. Pero ang matitira is in radian. And let's multiply by the factor 1 rev over 2 pi radian. Okay, at ang matitira natin dito ay 72 divided by 2 pi. The answer is 11.46. This is number of revolutions. Okay, nasolve na natin yung unang requirement. At yung pangalawang requirement, napakadali na lang kasi ang hinahanap lang dito is how far is the distance covered in this scenario. So, nasolve na natin yung theta, magmumultiply lang tayo ng radius. Diba? Napakadali na lang. For letter B, pinapahanap sa atin is yung linear distance or linear displacement. That's S is equal to R multiplied by theta. And R in this scenario is 0.3 meters multiplied by, this is meters per radian, multiplied by 72 radian. Diba? Okay, cancel of units. And then S is equal to 0.3 multiplied by 72. The answer is 21.6. And this is in meters. Okay, so sound and sweet. Ito na yung final answer natin sa last problem for rotational kinematics. And dito na din nagtatapos yung ating discussion for kinematic problems and also yung kinematic subject natin or topic. So, ang susunod nating discussion would be about kinetics naman. And mas exciting to kasi ito na yung mga forces or ito na yung mga motion na merong references sa forces. Okay? Pag-uusapan natin doon yung mga laws of motion, mga potential and kinetic energies, power, and so on and so forth. Okay, so pretty exciting discussion. Thank you so much for listening and hope to see you on my next videos. God bless everyone. Bye-bye.